So this is a video tutorial on how to use Google Sheets to graph your integrated rate law graphs. The three graphs you're going to be graphing would be concentration versus time. The second graph would be ln of concentration of A versus time. And then the third graph would be reciprocal of concentration versus time. The first thing you want to do is copy and paste your concentration of your reactant versus time. So that's your base graph. And then you're going to graph all the other ones with that. So how do you get these data points right here? So once you have copy and paste into your spreadsheet, the concentration versus time data points from the graph or from the data table, you will then start formulating the equation for you to create or find the value of ln of concentration of A. So what you're going to do is, if you look up here, this is f of x. This is your function, your output, your what is called your dependent variable, your y, equals. So you want equals. So you press equal. So now you're creating a formula that is based on ln. So you type ln. And when you type ln, you'll see the word ln. Click on it. And that will, the value you want in here is the concentration of A. So you click on that, which is your B2. Notice how it pops up B2, which is this column right, or this cell right here. Put in parentheses and then equals. And this is your ln of concentration of 0.2, basically. And so you copy and paste whatever that formula is. You select on that same cell, you control C it, and then control highlight all the ones that you want the same function in, and control V. And notice all the values appearing from there. I'm going to open this up so I can see more digits if needed. And then let's go ahead and do the same thing over here with the reciprocal of the concentration, opening it up a little. Equals, once again, f of x equals, you'll see it up here as well. And what you're doing is you're taking the reciprocal, so 1 divided by, and so it's just the slash symbol, concentration of A, which is B2, and then enter. And so you've got your reciprocal of 0.2, which is 5. Now I'm going to copy and paste that formula into all the ones subsequent to that, and those are my reciprocal concentrations of A at different times. Okay, so let's go ahead and graph now. There's two places where you would insert your graph. This is the insert graph chart here, a button, and then you also can insert your chart using going into the insert here and then go to chart. So there's two possible places. If you don't find it here, go ahead and insert chart right here. You have to highlight your data points, and you want to highlight the heading as well. That's why I put the heading there, is because it's actually going to automatically insert the heading title without you having to work at it. Okay, so I'm going to first graph my concentration versus time. My second graph would be my ln of concentration versus time, and then my third graph would be my reciprocal of concentration of A versus time. So I highlight my 2 points, and then I'm going to insert graph. The minute it inserts, you'll see a histogram graph. That's not the graph you want. You want actually it's called a column graph. You want a different chart type. So you go to this editor, chart editor, and you change it to the smooth line chart, okay? And you'll notice the graph. Now, it doesn't look quite linear, but the for sure way to tell if it's linear is if you go to Customize. So click on Customize, go to Series, and what you're going to do is add a trend line. So go down to the bottom where it says Trend Line. Click on it. You want a linear trend line, which is immediately the first default. There's other kind of trend lines, but the linear one is what you want. And you want the equation. So I'm going to click on Label Equation, and the equation pops up with it in the form of y equals mx plus b. So this is your mx plus b format. And then you want the r squared value. Showing the squared value, which is right here, helps us to discern whether how linear this graph, this original graph looks or compares to the line here. So how far off is this graph here from the line that best fits it? And it looks like it's quite far off. And how you know is if your R squared is 1, the closer it is to 1, the more linear it is, and the more aligned that original graph is to the best fit line. So we'll keep it like this. I'll make it smaller because I'm going to compare all three graphs. So you can widen it, make it smaller. So now we're going to graph the next graph. And the next graph is the ln concentration versus time. So I'm first going to highlight my independent variable, which is my time. And the way the Windows works, and I'm not sure about Apple, but the way Windows works is when I press Control down, I am able to selectively highlight the second column that I want to graph. So it's the ln of concentration. Once again, insert graph. Your original column type is, scroll up, it's column chart rather than what you want, which is the smooth line chart. Once you have your smooth line chart, you go to Customize, once again, Series, go down to Trendline. So you're going to add a trend line, and it's going to default to linear once again. You want to label the equation, so y equals mx plus b. So that's this line right here. That's the equation of this line. And you're going to show your R squared value. Now, the R squared value is a little better right here. It's unlike the previous graph, the R squared value is 0.588. This R squared value is 0.836, which is closer to linearity than the previous graph. So now let's compare it to the third graph. In the third graph, we're going to once again highlight the first column, and then I'm going to press Control once again to selectively select the reciprocal concentration of A. And then I'm going to click on the chart. I want to change the setup of that chart. I want to call it the smooth line chart. And look how linear this graph is. But let's be sure. Let's go to Series, add the trend line, linear, add the equation, and then the R squared. And look at how close this R squared is right on the mark to show that this graph is very linear and the most linear out of three graphs. So I really do want to show the equation of the three lines and, of course, the R squared value for each of these so I can compare which one is the most linear. Insert these three graphs into your constant or your assignment, and from there you will be able to tell the order. Now, because the most linearity occurs for the reciprocal concentration of A versus time, I know that this A, the reaction order for A is actually second order. And that's because the concentration of A versus time is linear right here. So that helps us to discern the reaction order. And it is second order with respect to A. Now, from the K constant, which is right here, this is your, remember, y equals m. This is your mx plus b. 5 is your b, y-intercept. This m is your slope, and that slope tells us your K constant. So this is your K. 5.98 is your K value. And that's why this this graphical method helps us nicely to discern not only reaction order, but it helps us to discern the K constant. And later on, you're actually going to see the integrated rate law from this understanding using this y equals mx plus b equation. So you can turn it into this is the integrated rate law, which helps us to determine any concentration at any point in time or half-life as well. So this is a very valuable set of information from just graphing it. All right. Hopefully you can practice graphing all the other example problems.